Okay, welcome to lecture 2.9. This one's going to be a little bit long, I think. What I want to do, and important, one thing I'm going to do is give what I call the recipe for creating a likelihood function. So it's very important. In fact, so important for your exam, I'm going to allow you to bring in a sheet of paper that has written down that recipe. For it's only 5 steps or 4. I can't even remember. It's not that hard to memorize. But the rule is, as I've done with previous classes, the exam will be closed notes, closed book, closed notes, except for this. So you can bring in this one sheet, which is your recipe, but you can do that only on one condition, and that is that you promise me that you will keep that sheet in your possession for the rest of your career. So if you want to use that sheet, you can, but you need to remember where it is and possibly use it and once you're an assistant professor, whatever. Okay, so I'll get to that in a minute. But most also, this whole lecture, it's basically, I'm going to discuss the Diermeier-Merlo paper and your homework problem, how you're going to use data from the Diermeier-Merlo paper. By the way, Diermeier-Merlo gave me their data, and they said I was welcome to give it to students. And so you're going to use their data to actually run a real problem, and that's going to be your homework problem. Okay, first of all, let's talk about some of the definitions in the Diermeier-Merlo paper. Okay, first. Okay, so now hopefully you've read at least the introduction of that paper, and I've talked a little bit about in the lectures about how there's kind of two beliefs when they wrote the paper, at least in the theory world, of how governments are formed and the way a government is formed. It all begins with who is selected formator, who gets the first chance at trying to form a government. And in the theory world, there's basically two different types of assumptions. Most papers took one of two. One was just that the largest party is the one who's selected formator. If that party can't form a government, then the second largest party is selected, and so on. By the way, who selects the formator? Like in Britain, it's the king or the queen. It's often a monarch, or sometimes it's some rule. Or lots of countries, it's kind of nebulous who becomes the formator. But there were some theoretical papers that said, "Oh, it's the largest party," and then I think it's Diermeier-Merlo actually said, well, maybe we want to have another theoretical model where that's not the case, and we don't want it to be totally deterministic. And they said, what if it's a probability, and it's the probability equals your share of seats? And some people gave him, I think, grief for that assumption. And they thought, why not write a paper to see what is true? Okay, so that's it. There's two competing theories over who becomes the formator. And so Diermeier-Merlo, they created independent variables to try to test this. And so what they have done, so I'm going to write it, pi sub I for observation t. So this is this equals. So unfortunately, they usually we use Greek letters for parameters, but Diermeier-Merlo, maybe unfortunately, I don't know, but they used a Greek letter for an independent variable. So don't get too confused. You see that Greek letter? It's not a parameter. It is data. So pi it, that equals party i's share of seats. So I'm going to write in country T. Okay, so I'm going to pretend like this is just a cross section of data. I think their actual data set, it's a time series. They have several countries and several years, but it's a little simpler to discuss if I just pretend it's a cross section. So it's only 1 year. So what I'm going to call observation T, that will be country T. Okay, so the key is pi I. Okay, party I share, and then Diermeier-Merlo creates a dummy variable, call it DIT, and this equals 1 if I is the largest party in country T and 0 otherwise. Okay, so those are their two main. They're two independent variables. Then they do this 2 ways. I'd say maybe their main way in their paper is they discuss the probability that party I will be selected formateur, and they call that PI. That's defined as probability I is selected formateur. Okay, and they assume for one part of their model, actually this is not your homework, but I'm going to write down what their other version, not related to your homework. I'll just go ahead and write that down. So assume that PI equals exponent expa e to the beta 1 times pi I t. So this is a probability that I selected formateur. Let's make it superscript t, an observation t, country t. So it's beta 1 times pi I t plus beta 2 times d I t. Okay, all divided by summation j equals 1 to, let's call it big J superscript t. J, I don't think Diermeier-Merlo used this terminology, but I will. JT equals total number of parties in country T. Okay, so we're going to sum over all the possibilities. So it goes sum j equals 1 to big J expa beta 1 times pi j t plus beta 2 dj to the t. Okay, so that's what they assume. We could use this to build the likelihood function. Okay, we could talk. I think by next week or the next week, you would have the tools. You would be able to do this. Okay, I'm not. Okay, so I'm going to just say here's what they do in their paper, at least one of their main sections. But we're going to skip this part. So now that I've written it, you're welcome to forget it. Okay. Here's what happened when Diermeier-Merlo wrote this paper. So, as you know, in academic publishing, they send it out to referees, reviewers, and usually they're anonymous. And I was one of those referees, so it's no longer anonymous. I've given myself away. And so I wrote in the referee report, I said, hey, you know what? I think that there's an even simpler model. They could estimate this as just a weighted average of those two independent variables. Rather than this more complicated version they did, they could set up a model where the probability is just a weighted average, and the weighted average would involve just one parameter. And I said, if you have just one parameter, you could estimate that parameter in a likelihood function in Excel. You wouldn't need to use an actual stat package. And so here is what I suggested. And by the way, when you get a referee report, always say nice things about the reviewer and humor him or her. And they did. They said, "Oh yeah, that's a great idea. We'll try it." And they put it in a section. So they humored me. And so what that is in that paper. Now here's what they did. So what I suggested, they said, instead, let's have a different model. PI equals PIT equals lambda pi IT plus 1 minus lambda d IT. Okay. Before they had beta 1 and beta 2, two parameters to estimate. Here they only have one. Lambda is the only one. Remember pi is an independent variable. Even though it's a Greek letter, it's an independent variable. D is also an independent variable. So all you got to estimate is lambda. And as I suggest, you can do that in a spreadsheet. And that's what you're going to do in your homework. Okay, you're going to estimate the lambda. So here's what you need to do. Okay, so you've got PIT. Okay, let me now write the recipe. Okay, and I'll come back to this board. Let me have a clean one. Okay, now let me write recipe for creating a likelihood function. Okay. Step 1 is create a dependent variable. Okay. So in this case, so e.g., let's call it big Y sub t. So big Y sub t is a random variable, and it just equals which party. So in country T, maybe there's 8 parties that could be selected. And so Y, big Y sub t, is just going to equal 1, 2, 3, 4, 5, 6, 7, or 8. Okay. All right. So that's our dependent variable. So observation T, got a variable. What is it going to be? Okay. 2. Note the actual values of the dependent variable. And let's put semicolon, and let's call those y sub 1, y sub 2, generic y sub t. Let's call it big T. We have a total of T observations. Okay. So big Y T is a random variable. Little y is the actual observation. So these are going to be numbers. So in country 1, say party 3 was selected. In country 2, maybe party 6 was selected. Say that's observation 10. maybe party 2 is selected. So those are going to be numbers, okay? I think probably the biggest case is something like 10 parties in a country. So all of these numbers are going to be something like 1 to 10. By the way, these are different countries, so different countries have different numbers of parties. So you have to kind of pay attention to that. Now, next, 3. Write the probabilities of observing those values. That is little y1, little y2, and so on. That is, i.e., so write probability y1 equals y1, where you'll substitute whatever its actual value is. That might have been 3. Right? Probability y2 equals little y2, and so on. Okay? You're going to have to do that for the big T different cases. Okay? Okay. Okay. For, in this class, assume the observations are independent. Okay. So then therefore, all these probabilities are independent of each other, these random variables. So that means the likelihood is just going to be the product of all those probabilities. Okay. Likelihood is the product of those terms. Okay, that is probability y1 equals y1 times probability big Y2 equals little y2, and so on. Okay, probability of those terms. Okay, great, and that's it. Once you've done that, okay, you should be able to. You have the likelihood function in your Excel spreadsheet, or maybe you've programmed it in R or Stata, whatever. For your homework, you're going to do this in Excel. And by the way, some people say, can we do it in R? And said, no, I want you to do it in Excel. And someone said, but it's so much slower when you do it that way. And can we do it in something else? The answer is no. And the reason why is because if you've ever seen the movie Karate Kid, I think I'm Mr. Miyagi. And you remember Mr. Miyagi is teaching the Karate Kid to do the wax on, wax off. And he gets the kid to do these household chores for him, to wax his car and all. But then later, he's doing all this stuff that seems like grunt work. And then he realizes, oh, I've learned karate without even realizing it. And so that's what, the genius of Mr. Miyagi. And so, if you think this is grunt work, having to do this in Excel, it'd be so much easier to do in R or some other program. Just say, no, you got to do the wax on, wax off, okay? Because I am Mr. Miyagi, okay? So we've got the recipe, okay? So now, for your homework problem, okay, here's what you're going to do, okay. You are going to have your data, and it's going to be something like this. Data, and say in the first case, so in country 1, say party 3 was selected. In country 2, observation 2, say country 6 was selected, and so on, okay? So what you're going to need to do, you're going to write L, I could have written log of L. It should be simple. Once we get the likelihood, it's easy to take the log of the likelihood. So normally I've been writing L of theta, okay, but now I'm going to write, we only have one parameter to estimate, and that's lambda. So now we have L of lambda, and this is just going to equal probability y1 equals 3 times probability big Y2 equals 6, and so on. All right? Okay. So remember that, okay? Get that down. Write down that recipe function and then apply it, okay? Look back and forth and say, okay, I've done that. Okay. Now, the key is, here are these probabilities. Probability in country 1, party 3 was selected, is this. It's this. So it's going to equal lambda times pi 3, okay, party 3. That's the probability that party 3 was selected. And so we use pi 3 for observation 1. So you'll need to look at what party 3 is in country 1. Okay, plus 1 minus lambda pi, no, not, what do I do with it's not pi, it's d. D 3t, that's a 1 or 0 variable, okay, times lambda times, now we're in observation 2, pi 6. So observation 2, it's the probability that party 6 was selected formateur. So it's pi 6 observation 2 plus 1 minus lambda d6, dummy variable, whether party 6 is the largest party or not in country 2, times so on. So you have to look at this for observation 3 and so on. Okay. Now, I want you to notice something. Okay, let me give you some hints on this homework. In fact, this is something that almost every year some student gets wrong. Okay. Notice that for observation 1, we only looked at the independent variables associated with party 3. We didn't care about what the independent variables were for party 1, party 2, party 4, party 5. That's not in there. We don't have pi sub 1, observation 1, pi sub 2, superscript 1, and so on. Those are not in there at all. Okay. Now, here's why it's tricky. Because I decided when I made this homework problem, I would give you the data that I got from Diermeier-Merlo. So I asked them for their data. They sent all of it. Okay. Now, hopefully some of you are fans of The Simpsons, and there's one episode where Homer is building some child's toy or something, and he's got the instructions, and after he completes it, Homer says, "How come they always give you more parts than you need?" Okay, and the joke is he didn't put the toy together right if he had all these parts that he's not using. Okay, you're going to think that. Okay, I gave you all the data that Diermeier-Merlo sent me. You're not going to use all that data. You're going to have, why did they give you why did my professor give me parts that I don't need? Okay, you're going to have data. So for country 1, there's going to be something like 7 or 8 parties. I don't remember how much. For observation 1, there's going to be 7 or 8 parties. You're only using the data for party 3. Okay, so something like 7/8 of the parties you're not using that data at all. You could throw it away. Okay, you can go through your spreadsheet and just delete those cases of parties that were not selected formateur. That's what this likelihood function implies. Okay, so remember that. Just remember, here's how you do the likelihood function. Okay, now more specific. Here's another way of putting it. So the likelihood, so L of lambda equals this. Okay, L of lambda is not equal to the following. Here's what a lot of people want to do. They want to say, instead they write L of lambda equals probability y1 equals 3. So observation 1 equals times probability y1 does not equal 1 times probability. This is observation 1. Probability y1 does not equal 2 times probability y1 does not equal 4, and so on. And then you look at the next one, times, for observation 2, probability y2 equals 6 times probability y2 does not equal 1 times probability y2 does not equal 2, and so on. Okay, that's not the correct likelihood function. Okay, here's a way of thinking about it. Suppose you did a regression, okay, and you've got 100 observations, you got 100 cases where you're dependent variable, and you've got for each of those observations what your value of all your independent variables are. Suppose you run the results and you're not getting significance on for your third independent variable, beta 3, whatever it is. And suppose you're thinking about sending this to a journal and you think, I wish I had significant results. What if I just duplicated my data? So if I have 100 observations and I just duplicate that 4 times, and so I have 400 observations. Okay, yeah, it's 4 observations of the same first case, 4 observations of the same second case, and so on. If you do that, you'll get more significant results. You duplicate it enough times, you'll get significant results. You'll get your sample size up. Now, the problem is the statistical test that you are doing assumes that all of your observations are independent from each other. And so if you just duplicate your data, that's no longer true. So your first observation, not only is it correlated with your 101st observation or your 201st observation, they're exactly the same. They are correlated with a correlation coefficient of 1.0, okay? What you've done is not kosher. You cannot do that, okay? Now, I've actually heard I don't think anyone is, there are very few people are that stupid to think that they can get away with that. Now, I have heard of a case. A friend of mine was a referee for a journal, and and they had something like time series data, and so they had one of their independent variables was, say, the year. So it was 1901, 1902, 1903, 1904, so on. And what they did is they weren't getting significance. So what they did is they took the average of contiguous observations. So they took their year 1 observation, year 2 observation, and then averaged them, dependent variable and independent variables, and then called it year 1.5, something like that, and added it to their data set. So all of a sudden they doubled their amount of data, and they were impressed with themselves. This allowed them to get significant results. And of course, my friend who's the referee said, no, you can't do that. Your statistical tests assume that your data, your observations are independent of each other, and what you're doing, they're exactly not independent when you're just taking the average of 2 contiguous observations. Okay, the same thing is going on here. So this is the correct likelihood function. When you write it this way, what you're essentially doing is you're adding observations. So you're saying our first observation says in country one picked party three. Our second observation is to say in country one, they didn't pick party one. Our third observation says they didn't pick party two, and so on. All of a sudden, if you do it that way, your observations are not independent. In fact, so if you told me for observation one, they picked country three, and then you say, well, and then observation two, it also involves what country one picked. And I can say, well, I already know that party one is not picked because you already told me that party three was picked. So this observation, so the data in that observation is not independent of the data in your first observation. So this is like those cases where you're just adding data, like copying data from your original data set. Okay, so you do not want to do this. Okay, be careful. Every year I'll have one student or two or something. It's a easy thing to do, and it's partly because I gave you the data set. You're going to think, oh, I've got all these observations. I've got the observation of the data on party three in country one, but now I've also got data on party four in country one. What am I supposed to do with that? And the answer is throw it away. Okay, be like Homer. You don't use it. Okay, don't do something like this where you try to force yourself to use those extra observations. Okay, so that's the way you create a likelihood function. Okay, now what I would do if I were you, I would take the sample likelihood function I gave you. From that, rewrite it so that it involves this likelihood function, and then you're going to also have to take the data that I've sent you, or that is on Dropbox right now, the Diermeier-Merlo data. You're going to create the likelihood function like this, and then I asked you, gave you different criteria. I said try two cases, one where it's only Germany and Ireland data. I can't remember exactly. And then when it's all the countries. And for each case, for the two different cases, estimate lambda. And then I also ask you to do things like run statistical tests on what various hypotheses for what lambda could be. And I can't remember exactly what I wrote. I think one was test whether lambda equals 0.5. I think that's one. Go with the sheet I gave you that's on your homework assignment. So you'll do that. So you can do things that I've already told you. One, you can do like a likelihood ratio test. You can also use the t statistic we said, because that lambda hat, your maximum likelihood estimate of lambda, we've got that result that asymptotically it is going to be distributed normal, okay, with mean, whatever the null is, okay, if the null is true, standard deviation equal to the second derivative of the likelihood function, okay, or more specifically, the negative of that second derivative inverted, okay, take 1 over that value. That's going to be the variance, okay, and you take square root of that, and that will be your standard deviation. Okay, and I think from that you are ready to do the homework. Okay, let's see. Okay, yes. Okay, that's all my tips on the Diermeier-Merlo homework. Sorry, this one went more than 34 minutes. Okay, so this is, I can't remember. This is lecture 2.9. Okay, so I still got some little more odds and ends to do, so I'm going to see you in lecture, this is 2.9, I'll see you in lecture 2.10. Okay, see you there.